Good everyone, my name is Graphics. We'll solve this problem involving electromagnetism. We'll be looking at an inductance, right? And the question goes like this. It says, the total inductance of two coils A and B, which is connected in series to 0.5 Henry or 0.2 Henry, depending on the relative direction of the current in the coil A when isolated from coil B, has a self-inductance of 0.2 Henry. Calculate A. Mutual inductance between the two coils. B. Self-inductance of coil B. C. The coupling factor between the coil. And Roman figure 4 and will give us the two possible value of the inductance of the induced EMF in the coil A when current is decreasing at 1000 ampere per second in the series circuit, right? Now we're told that the total inductance of coil A is 0.5 or 0.2. Are you with me now? It can be any of the two. And the total inductance of coil B can also be 0.5 or 0.2. So whatever you want to assign to them, you can do that, right? So I can just take that my total inductance for coil A is 0.5, right? And my total inductance for coil B is 0.2. Now recall, we know very well that for series opposing, we say that my total inductance L is equals to self-inductance 1 plus self-inductance 2 minus 2 times the mutual inductance. Is that okay now? Now, we would say that this is for this inductance here is for coil A, total inductance. So I will say that what 0.5 equals to self-inductance 1 plus self-inductance 2 plus what? 2 times the mutual inductance. That will be my equation 1. Similarly, I will consider that for what? 0.2 now, right? So similarly, I will say that for aiding, for series aiding, the total inductance is equals to the self-inductance 1 plus self-inductance 2 plus 2 times the mutual inductance. Is that okay now? So that is my LB. So I'll say 0.2 is equals to L1 plus L2 plus 2 times the mutual inductance, right? That is 2M. That will be my equation what? Equation 2. So it can be any. You can decide to make your equation 1 have 0.2 and your equation 2 have 0.5 depending on what you want to do. So we'll proceed. Now what I will do is I'll try as much as I can to avoid negative, right? So I'm going to subtract equation 2 from 1. Is that okay now? So subtract what? No matter what you do, you try to subtract the lower inductance from the higher inductance. Is that okay? So I'll be having 0.2, I'll be having 0.5 equals to L1 plus L2 minus 2M minus 0.2 equals to L1 plus L2 plus 2M. So when I subtract 0.5 minus 0.2 will give us 0.3. L1 minus L1 will cancel out. L2 minus L2 will cancel out. 2M minus minus 2M, that means 2M plus 2M. That will give us what? 4M. So if I make my mutual inductance the sort of formula, I will have my M to be equals to what? 0.3 over 4. And my mutual inductance will give us what? 0.075 Henry. So in this part here, we have successfully calculated for what? The mutual inductance. Now the next one we are going to be calculating for will be for the self-inductance for coil B, right? Now we do the same thing. We know very well that for aiding, my total inductance is equals to L1 plus L2 plus 2M, right? And we know we take that to be we take it to be 0.5 equals to L1 plus L2 plus 2M. That is my equation 1, right? Similarly, we do that for when it is what? When it is opposing, it will be L is equals to what? L1 plus L2 minus 2m, right? And we'll take that to be 0.2 equals to L1 plus L2 minus what? 2m. That'll be my equation 2. So the first time we subtracted, but now we are going to be what? Adding equation 1 and what? Equation 2. And the reason why we're doing that is this. So when you add both of them, 0.5 is equals to L1 plus L2 plus 2m, and 0.2 is equals to L1 plus L2 minus 2m. When you add them, 0.5 plus 0.2 will give us 0.7 equals to L1 plus L1 will give you what? 2L1. Then we have L2 plus L2 will give you what? 2L2. Now 2m plus minus plus times minus will give you what? Minus. So 2m minus 2m will give you what? 0. Now, we know from the question that we're given the self-inductance L1, right? From this diagram, it says that the self-inductance L1 is given to be what? 0.2. So we're given the self-inductance to be what? 0.2, right? So from here, if I input it into this equation above, I'll be having 0.7 is equals to 2 multiplied by L1 is 0.2 plus 2L2. So if you do the needful, 0.7 will now be equals to 0.4 plus 2L2. So if I take 0.4 to the other side, I'll be having 0.7 minus 0.4 is equals to 2L2. So, and 0.7 minus 0.4 is 0.3, right? Equals to 2L2. So L2 will now give us 0.3 over 2. So my L2 will now be equals to what? 0.15 Henry, right? So that will be my self-inductance of what? Of the coil, right? That is my L2 of the coil what? Of the coil B. Is that okay now? Now, we've gotten that. Now we look for the coupling factor between the coils. Recall, we know the coupling factor K is given as what? The mutual inductance all over the square root of the self-inductance 1 minus times the self-inductance what? 2, right? So the self-inductance of coil A times the self-inductance of what? Of coil B, that is L1, L2. Are we there? So my coupling factor now, K, will now be equals to, you input your values, M is 0.075 divided by the square root of 0.2 times 0.15, right? And this will give us 0.075 divided by, if you look for the square root of 0.2 times 0.15, you'll be having 0.1732, and that will give us 0.434. And if you multiply by 100, you'll be having 43.4%. And that is what my coupling factor K is in percentage. Now, aside from that, right, we are told to calculate for the two possible values of the induced EMF, right? So if we do that, we say that the volts of the coil 1, right, that is the volt here, is given to be L1 times the I over the T, that is the inductance times the rate of change of what? Of the current, plus or minus the mutual inductance times the rate of change of the current, right? Multiplied by what? 1000. So we know that my E1 now, which is the volts, right, is equals to the voltage here is equals to the inductance, the self-inductance 1 is given to be what? 0.2, right, as you've calculated earlier, plus the mutual inductance, right, that is what? 0.075, which we've calculated for, all multiplied by what? 1000, right? We'll do that when it is positive, we'll add them, and we'll subtract them. So when you do for that, you'll be having 275.5 volts. Then when you do it, when you both of them are subtracting each other, so we have E1 is equal to 0.2 minus 0.075, and that will give times 1000, and that will give us what? 125 volts. So this is what the possible values of the induced EMF. Is that taken? Right? So this is what we have here. If you have found this video helpful, Please don't forget to like, subscribe, and also share the video. Thanks for watching.